Hi everyone! In this demo we are going to showcase Valentine, a scalable schema matching system that supports two discrete schema matching use cases. In the first, a user can fabricate synthetic datasets or use existing ones to evaluate and compare existing schema matching methods or test with their own matcher, facilitating a testbed to simplify the development and evaluation of new or existing methods. Imagine that we are a researcher trying to create a high-performance schema matching algorithm. A significant challenge is to find high-quality data to test on. So the user goes to Valentine and provides a CSV file that will serve as the basis for the dataset fabrication process. In this example, we are using a dataset from René Miller's group. Then the user can select to cover all schema matching scenarios as defined in Valentine, set the number of pairs for all cases, the types of pairs to generate, and make the request to Valentine to initiate the dataset fabrication process. In the next tab, the user can inspect the created dataset pairs by selecting the Show Sample button without having to download any large files for manual inspection and see if the datasets meet their needs. Finally, they can download the pair or even the entire dataset group for local testing. Now, if the user wants to test their algorithm at scale by specifying an extensive grid search with a comparison against the state-of-the-art methods, Valentine has them covered. On this page, the user can do just that. For this example, let's select our previously created fabricated dataset and then select some schema-based algorithms. Let's leave some of them to their default parameters and specify the grid search for Cupid. The user can either separate the values by commas or provide a range input using the MATLAB notation, like in this example. Finally, submit the created job to be run in parallel in Valentine's scalable elastic job queue. On the last page, the user can view the submitted grid search results in the form of a box plot by clicking on this button and see all the results that negatively affected the algorithm's performance for each pair when clicking the Show Spurious Results button. For this example, the algorithm found all the results, so there is none. Now let's go back and see our second use case, where the users would be able to perform holistic matching in a data lake that contains all the data sources of an organization with the goal of finding links between them. On the first page, we see an overview of all the integrated sources in our data lake, a Minio bucket and the Postgres database. The Minio bucket contains a dataset that we crawled from Wikidata containing musicians, and Postgres contains a similar Wikidata table with alternative musician names. Let's select them to define the algorithm's search space. Then the user can select from all the integrated algorithms of Valentine and define their parameters or use the defaults. Let's select the defaults for comma and specified qubits parameters. Here we would also like to mention that Valentine is extensible by design, meaning that users can easily integrate their own methods. Now let's go and see whether the algorithms have provided any actual link recommendations. Since schema matching is an AI-complete problem, user input is an integral part of finding matches, and we made sure to make it as simple as possible. Instead of complicated line visualizations, we display the matches as a sorted list of matches with the higher similarity on top. So the user can start right away to verify or discard matches, and if they are unsure, they can click on the proposed match to view a sample, like so, from the actual data inside both of the proposed columns. Finally, the users could look at the verified matches and gain some very useful insights about the links within their data lake. Thank you for your attention.